All right, in the last video, we kind of finished with the formula for calculating a one sample z-interval for p. So now let's review the conditions from our sampling distribution chapter. In order for our 98 or 95 or 90, whatever percent confidence interval we're calculating, in order for them to accurately capture the true proportion 98% of the time, the following conditions are necessary. So random, the data just comes from a well-designed random sample, or with no bias, or a random experiment. The 10% condition when sampling without replacement, which is what we always do. Our sample size needs to be less than or equal to 10% of the population size. And large counts is NP greater than or equal to 10 and NQ greater than or equal to 10. Now we have a problem here again. We don't know P and Q, so of course we're just going to put in our sample estimates for those values. All right. Why are each of the above conditions important? Well, the random condition is important to assure us that our p hat will be an unbiased estimator. For p, it's a guarantee that the center is going to be at the right spot, right? When I take my p's, I want to be assured that my p hats, if I were to take multiple samples, which of course we're not going to do in practice, but in theory, if I took many, many samples, I'd get a collection of p hats. This is called the sampling distribution, as you know. Those things should be centered about the true value as long as you take a random sample. 10% condition. This assures us of the formula that we use. This allows us to use the formula for the spread. The 10% condition is kind of gives us this pseudo independence. Not perfect, of course, but means our lack of independence doesn't affect this formula very much, the PQ over N. Technically, if you're sampling without replacement, this shouldn't be the formula, but as long as your sample size is small relative to your population size, this formula will be suitably reliable, and therefore we can estimate it with we got levels of estimation upon levels of estimation, but that's stats for you. And then the last one is the shape check. It's to see if the sampling distribution to assure us, is that the right word? I don't know. To assure us that and you're going to write this down on every problem for me, that the sampling distribution of p hat is approximately normal. Okay, that's what the check is for. It's to assure us of this. So all of these things together assure us that we have the right center, we have the right shape, we have the right spread, so that when we calculate our confidence interval, that our 98% confidence intervals are really going to capture the mean 98% of the time as advertised. So this is not a College Board thing, but I do like this mnemonic to help us remember the steps for a confidence interval. So when we do a confidence interval, I'm going to ask you to panic. P, find the parameter of interest. State the parameter of interest using the correct symbol, words, and don't forget context. Assumptions, check the assumptions and conditions. N, name the test, name the interval, and give the formula. I expect both of those. And then I, actually calculate the interval, get your actual interval. Now if you give the formula and you give me the interval, I don't actually need any work. This is kind of good enough for the work. And I am going to show you a shortcut on the calculator, but do at least one or two by hand, or I would recommend that anyway. And C, state your conclusion, interpret it in context. All right, it's easier than you think, but they do get kind of long because you got to check 3 things here, and it just adds up to a pretty long problem. Pennies. Mrs. Quinn's class took a simple random sample of 102 pennies and discovered that 57 of the pennies were more than 10 years old. Calculate and interpret a 99% confidence interval for the true proportion of pennies from the collection that are more than 10 years old. So my sample size is 102. My p hat is 57 out of 102. You could calculate that if you want. I don't actually really need to, or I'm not going to. All right, so here we go. First step, P. What is the parameter of interest? The parameter of interest is a proportion. The true proportion symbol is also P. Please don't get these P's mixed up. This will always be P. Next chapter, this is going to be mu. Okay? So, but it is a proportion here. So this is and it's actually given to us in the stem of the problem. The true proportion of pennies from the collection that are more than 10 years old. So I guess we just copy that down. The true proportion of pennies in the collection that are more than 10 years old. Good. Step A, assumptions and conditions. First assumption is random. Was the sample random? She took an SRS. Class took an SRS. I expect the condition and a brief statement. Okay, you don't have to write a paragraph, but I want a statement. If you just say random check, I'm marking it wrong. 10% condition. Probably checks off. We got 102 pennies, so is n equals 102, is that less than 10% of all pennies? Well, I don't really know. I don't know how many pennies were in the collection. This is kind of why we call it an assumption, not just the condition. So the condition is a 10% condition. My assumption is that there's more than 10%. There's more than basically 1,020 pennies in the collection. So that's going to be my assumption. If I'm wrong, then this check fails, and my interval is not going to be reliable. Actually, it's going to be more reliable because this is a good check to fail, but whatever. If any of these conditions fail, your 99% interval will not capture 99% of the time. Here it's going to capture more, here it's going to capture less, here it's going to capture less. But let's not worry too much about that. I'm going a little too much into it. Last one is large counts. Let's check it. NP hat, that is 102 times 57 out of 102, my p hat, that's 57, so that's greater than or equal to 10. And q hat is 102 times 1 minus 57 over 102. It's big enough. I don't really even care to see what it is. Then you have to give me this statement. I do require this statement. Therefore, the sampling distribution of p hat is approximately normal. I will just point out that this is why most kids lose a point on my test, because I do expect this. When we prepare for the AP test, we'll throw it out because you don't actually need it on the AP test, but whatever. I'm expecting it, so you got to give it to me. Panic, so I was going to put a C. N, name the test. This is a one sample Z interval for P. Oh my gosh, please do not, you did not see that P hat. I did not do that for P. Don't put P hat. In fact, if you're not sure which one to put proportion. That's good enough. If you don't know which one, put the word proportion. If you put P hat, it's going to be wrong. And then I got to give the formula. The formula is P hat plus or minus Z crit times the square root of P hat Q hat over N. Next step is to calculate the interval. So let's plug in our values. 57 out of 102 plus or minus. All right, so what is a z-crit that corresponds to 99%? So if you don't remember it, you have to calculate it. Draw the normal curve. I draw the normal curve. Want 99% in the middle, 1% on both tails, 0.005 on one tail, inverse normal, but I remember it. It's 2.58. Square root of p hat, 57 over 102, q hat, 1 minus 57 over 102, all over 102. All right, so I put it in my calculator here, exactly like you see it there. If I hit enter, it gives me the upper bound. And if I grab this thing and hit minus, it should give me the lower bound. So 43.2 to 68.6. 43.2%. Let's do decimals. 0.432 to 0.68. What's 686? 686. Last step, panic, conclude. We are 99% confident that the interval from 43.2% to 68.6% captures the, and by the time you've done all of this, you've forgotten what you're even talking about. Oh yeah, that's right, we're talking about pennies. Whatever you wrote right here, copy it word for word right here. The true proportion of pennies in the collection more than 10 years old. There we go. We're 99% confident that the interval from blah to blah captures the true proportion. Don't say we are 99% confident that the true proportion is in our interval. Say we're 99% confident that our interval is going to capture the true proportion. It's a subtle difference, but and you might be safe by using the word confidence instead of probability, but I wouldn't risk it. Is it plausible that 60% of all the pennies in the collection are more than 10 years old? Well, any number in this interval is plausible. 60% is in that interval, so yes. 60% is in the interval, so it is plausible. Whatever plausible means, right? Okay. Now I'm going to take another minute here to show you the calculator command. You're going to want to use this. Please go through the whole procedure once. But once you get to this stage here, if you don't want to type this in to get this, there is a calculator command for it, and it's really easy to use. You go to Menu, you go to Statistics. What option looks sensible here? Confidence intervals. Now you do need to know which one to run. These first four are for means, 5 and 6 are for proportions. This is a one sample z-test for proportions, so I'm going to select option 5. How many successes? 57. Sample size, 102. What level of confidence do you want? I want 99. I guess I can't just 99. And it calculates the lower bound, the upper bound. P hat, by the way, I never did actually calculate p hat. I never did take this divided by this, but it is 55.9. That's the middle number. There's a margin of error. There's our sample size. You can use this on a test. You really can. But I still expect you to give me the name. I expect the formula. For the formula, you can give me either of these two. You can give me this formula in symbols, or you can give me this formula with numbers. But use a calculator if you want, okay? Finding sample. Oh, we got another video.